All right, welcome back. This is Quad7 part 2. What we talked about is we're talking about 3 different ways to sketch parabolas, getting some axis of symmetry, getting our vertex, getting our y-intercepts. The 3 versions, we've got standard form, we've got vertex form, and I called it intercept form. You can also call it factored form because that is what we're starting with, right? So we've got this factored form here also. If you want to update your notes on page 1, that what I called, let's go back up a little bit here. Let's see, the intercept form, you could also call it factored form as well, this third type, because it is factored. Factoring, your favorite thing in the entire world. All right, let's go back and take a look at what we're looking to do with this right here. So in factored form, we've already got our intercepts, our x-intercepts. That's why I call the intercept form as well. So what we need to do is figure out what our 2 intercepts are. And then what's kind of cool is the x coordinate, like halfway in between those, that's our vertex. So in this first case, I have negative times x minus 6, that's like -1, by the way, times x minus 6 times x minus 2. Our first one here, x equals 6, that's our first 0, right? If I'm solving for it. Our second one would be 2. So we've got 2, 0 and 6, 0. We know those as our y-intercepts. I'm sorry, our x-intercepts, because that is where y is 0. We set them equal to 0 and solve. Those are our intercepts. Halfway in between, what's halfway in between 2 and 6? Because that's our coordinate for our x coordinate, right? Halfway in between 2 and 6 happens to be 4. Our vertex, our x coordinate of the vertex is 4. Because what we do is the first solution plus the second solution divided by 2. 6 plus 2 is 8. 8 divided by 2 happens to be 4. So we've got the coordinate of the vertex. Now here's something kind of cool too. We've already got 2 more points. It's technically 1 more point, but we've got that, right? We've got symmetry on either side. Okay, I'm getting ahead of myself. Let's go ahead and figure it out. Value of the function, because we need a y coordinate in here too. -1 times 4 minus 6 times 4 minus 2. Well, this is like -1 times -2 times 2. Well, -1 times -2 is 2. 2 times 2 is +4. So 4, 4 is our vertex. 4, 4 is our vertex. Now this one looks like it's going to open down. Would that make sense? Well, yeah, because our a is -1. So this is all making sense, right? What are some easy values to pick? Well, let's pick the things we know. We've got when x is 2 and when x is 6, our y is 0. Let's pick this one, 2 and 6. We need those are both zeros. No, those are both zeros. That's kind of nice. And let's see, it's easy to pick value in between 2 and 4. Let's see what's a nice value in between 2 and 4. Yeah, 3. So if I know what 3 is, I also know what 5 is going to be based on symmetry. Let's plug in 3 here. The value of the function when x is 3 is -1 times 3 minus 6 times 3 minus 2. Well, 3 minus 6, this is -3, -1 times -3 times 1. -1 times -3 is 3. 3 times 1 is 3. So 3, 3, and 5, 3. 3, 3, 5, 3. We've got our parabola here. Okay. What are some things that we don't have? Well, we've got our vertex. We got this guy right here. This is my vertex. I don't have my axis of symmetry. X equals the x coordinate. X equals 4. Vertex, sketch, axis of symmetry. I don't have my y-intercept. My y-intercept, again, that's when what? What value do we know on the y-axis? X is 0. So plug in 0 for x. This is like -1 times -6 times -2, because if I plug in 0 for each of those, that's what I get. -1 times -6 is +6. 6 times -2 is -12. My y-intercept, even though I didn't use that value, it's still there. It's still something we can have and still something we can see if we needed to. I've got my vertex, I've got my axis of symmetry, I've got my y-intercept, and I've got the sketch of my graph. Same thing we've done before, right? This is also a maximum. You're going to need to know that one too. All right. Now, what's the next thing you say? Well, you got a couple of them to try. What I want you guys to do, try this example here, the next one, and then you've got 2 examples on page 5. Try both of those. Again, a couple extra questions here just to make you think. When you're done with those, come on back, check your answers. We'll go a little bit at a time. Again, we're right here. This example first, and then the examples on the last page. Pause now, come on back when you are ready to check. All right, let's go ahead and take a look at this first one. Make sure your guided notes do say 2 times x plus 1 times x minus 2. Not x minus 4, x minus 2. If we do this, we take and find our x value there of our vertex. We do -1 and 2, because those are our 2 x-intercepts. Halfway in between those is +1/2. Oh, fractions. Oh no, whatever will we do? Well, use them. You've got 2 times half plus 1 times half minus 2. You end up with the value of the function when x is half is -1/2. So 0.5 and -4.5, or 5/10 and -4 and 5/10. You can graph that point. Then you can find a couple values. Well, what's half lower and half bigger than half? So how about 0 and 1? And 0, that helps take care of your y-intercept, right? Takes care of your y-intercept. And using symmetry, you only got to find one of those things. If you plug 0 in, you've got 2 times 0 plus 1 times 0 minus 2. You end up with -4. So 0, -4, and 1, -4. And then it just so happens that -1 and 2 are next, which is kind of nice because those are your x-intercepts. You already know what y is when you've got an x-intercept. Y is 0. You've got -1, 0, and 2, 0. From that, you can sketch your graph of those 5 points. You've got your vertex, you've got your axis of symmetry, you've got your y-intercept, and you've got your sketch. All right, on to the last 2 there. All right, on the last page. Those are some answers to check there. Again, your x and y tables might look a little bit different. I would highly, highly suggest, though, using your x-intercepts as your advantage and make those a couple of your points on there. Other than that, it's up to you. You could have picked any numbers that you want, as long as you got a couple that are less than your x vertex max. I'm sorry, your x vertex, and a couple that are greater than. And again, use that axis of symmetry. Use that axis of symmetry. In this first one, our axis of symmetry, it's not written explicit. Oh, it is written there. X is -1. Our vertex is -1, -8. Axis of symmetry, x equals 6. Our vertex is 6, 2. Then we get into some things. Remember, opens up, opens down, max or min. We know it opens up because a is positive, making our vertex a minimum for the first one. Our second one, it opens down, making our vertex a maximum. Some domain and range. Again, our domain, -infinity to +infinity. There's nothing stopping it going from left and right. Our lowest value is -8. Our biggest value is +infinity. So I'd write those in there. Again, for number 2, same thing, -infinity to +infinity. Our range, the lowest is -infinity, the biggest is 2. It's a maximum, shows it right there. Remember, maximums too, increasing to decreasing, minimums are decreasing to increasing. Taking us back, right? All right, with that said, that takes care of our guided notes. Yes, that's a lot. It might feel like a lot until you've practiced. When you've practiced a bunch, it's just going to be like, oh, this makes sense. If I see this, I do this. But until you practiced it, it might not make a lot of sense. Go ahead, knock out practice, ask questions, and most of all, take care. Have a great day. See ya.